Well, welcome to another Wayne O's Photos video. And today we're going to be talking about power meters. And the reason why I want to talk about power meters is Meijing, another company, has actually brought out a very reasonable power meter. And one of my fellow Aussies, Shane Miller, he actually did a quick review on it and he found some issues with it. So go and check that out so you can find out about the power meter. But what the problem I've got with all these power meters is they claim their accuracies as a percentage variation. Now, 1.5% or 2%, and even the top end ones like the SRMs and that, which are quite expensive, like the ones that I've got on my Look bike. And if you haven't seen that video, go check it out. I did a review on them, and I actually even questioned the calibration certificate and how that was actually presented. But anyway, let's have a bit of a discussion about calibration and how calibration is supposed to work. Before we can claim that something's accurate, we need to be able to know what the actual measurement is that we're measuring. So if we're actually claiming that we can measure a watt, let's just say an average person of 250 watts, then we actually have to be able to know what a watt is. Okay, and that's actually related to international standards. There's bodies all around the world and they keep standards that have voltage and current and all that, and they can actually tell you what a watt is. And some of the labs around the world, it's incredibly accurate, and they have to keep standards to a very, very accurate point. Okay, so a power meter is still fairly inaccurate in reality to those labs. But the first thing you need to know, number one, you need to know what a watt is. So if we don't know what a watt is, how can we know that it has a variation? So just say you got 250 watts, how do you know it's actually not 251 watts? Because you have to be able to know that you can measure 250 watts to say it's 251 watts. And this is like my very first question to all of these manufacturers, because they're actually not saying what their actual accuracy of their lab is. And this is where I get to my second point, which is number two point. When you talk about a variation from a set figure, let's just say 1% or 1.5% or 2%, that actually is not a figure related to the piece of equipment. That is a figure related to the laboratory that measures the piece of equipment. So for instance, if I said my ability to measure 250 watts is 250 watts plus or minus 2%. So on any given day, it could be 0 degrees Celsius, it could be 40 degrees Celsius, or the humidity could change, or I may use different leads. Taking into account all of those variables, my measurement, if I repeat it over and over again, will be within that claimed variation, which could be 1.5% or 2%. Now, when we do modelling, we actually claim this to a factor of certainty as well. Now, I know I'm getting a little bit deep here, but what it means is that if you have a bell curve like that goes up and then over like this and then down and then like this, right? If I did say 1,000 measurements at all different temperatures and all different leads that I have in the lab that I could possibly use, all different bits of equipment that I may use, then if I have a confidence level of 3 sigma, that means 1 in 1,000, it would be outside of that percentage that I'm claiming for my lab. So when we say, what we should be saying is, when we talk about accuracy, saying my variance is plus or minus 1.5% at 3 sigma, or a confidence level of 99.9%. And that actually is the ability of the lab. It's not the accuracy of the piece of equipment. So when we actually have the piece of equipment, what that should come with is actually a correction or an error. Now, a correction is something you apply to the figure to get the true reading. Okay, I hope I'm not going too deep here and we're not losing people. So just say that again. The variance, like the plus or minus percentage, and the confidence level is the ability of the lab to measure, right? The actual error of the unit we're testing, right, is represented as an error. So that's like if it was 250, and it was actually reading 251, you'd say plus 1 watt. Okay? If it was a correction, you'd say minus 1 watt. So if you had 251, you would add the minus 1 watt and get 250, and then that would be the true reading. So that's how it all works, and that's how it should be represented when they actually have calibration certificates, or how they're actually presenting that data to end users. The plus or minus thing is a bit of a furphy, because if they can't demonstrate they can measure a watt, how can they say that it's 1.5 or 2% variation of whatever they're reading, because they don't know what a watt is, they don't know what 250 watts is. And typically, from my experience, is when you actually measure devices, they tend to have a bigger error at the lower end, because the force that's being applied is very, very small, and you're trying to get the device to measure a very small force, because once you go to a higher actual pedal strengths, you actually got a higher pressure. So I would probably say that most of these manufacturers would be kind of setting their most accurate readings, I would say, between 200 and 400 watts. And if you get 50 watts or 20 watts or whatever, is it really that important that it's not that accurate? So what you would find is that if I was giving, say, 10 points, I would give them across the range, say, from 10 watts to 400 watts. Then 10 watts would probably have the biggest error, and 400 watts will probably have a very low error. So that's how it's normally represented if you're actually having traceability, or you actually have to put out a report with accuracy figures on it that actually has some international representation, like NATA, for instance, and there's a number of these labs around the world. So my question to these manufacturers is, why don't they give us at least 1 point, like an accurate point, right? Because they, like the quality control, before that power meter leaves the lab, they could actually do a calibration check, maybe at 1 point only. It could be 250 watts, which is considered an average person. And at 250 watts, they could actually give an error for that particular unit. So when you open the box, you can see there's a calibration certificate, and it will say the error is this, or the correction is this. But we don't get that. And that's where my question mark comes. Now, to me, when I see these percentages like 1.5%, 2%, I kind of go, what the hell are they talking about? Are they talking about that they're saying that their whole batches are within 2%? And if they do that, they must have tested them. Or if they haven't done that, how have they done their variance and their confidence level using, either a 2 sigma point or a 3 sigma point? 3 sigma is 99.9, 2 sigma is, I think, around about 95 or something percentage. So even that can vary. But how have they come to that? And they don't actually give any information to represent that. They don't give any reports. Even with my SRM units on my look, all they gave me was a millivolt output. Now, that doesn't mean anything, because we're not measuring millivolts, we're measuring watts. We want to know what that piece of equipment can measure at a watt at different points through its measuring range. Well, anyway, guys, I hope that clarifies how accuracy calibration actually really works, and why these percentage figures really are pretty meaningless in the whole scheme of things. Now, I know people like Shane Miller actually compares to other devices. Now, what that does is that gives you a consistency. What they're saying is that all these meters, they generally work pretty similar. So you can say that, hey, right, are they all wrong or are they all right? And even then, even though they're the same, how do we know at 50 watts they're not reading 70 watts? And how do we know at 250 watts they're not reading 260 watts? Because the design parameters of these power meters has that sort of error in them, because, at that price point. We don't know. Well, anyway, that's where I'm going to leave it. If you have any questions about it, just leave them down below. It's a little bit of a kind of a field where you have to dive deep, and there's modeling and all that sort of stuff. I won't get into that. But I just wanted to clarify this whole thing about plus or minus, whatever, really is not a representation of the device you're buying. It's a representation of the lab's ability to test the device. Okay then, guys, thanks for watching, and I'll catch you next vid.